and welcome to Jogvid with Miss Whittaker. Write down today's date, underline it, then start the Do Now quiz in the black box. Pause me while you give that a go. Off you go. Okay, let's green pen our Do Now quiz then. So, correct your answers in green pen using the answers on the next page. Let's scroll down. The answers for the Do Now quiz are in the green box. So A, a layer of gas that's around the Earth, that's the atmosphere. B, greenhouse gases, e.g. carbon dioxide, methane and nitrous oxide. I say carbon dioxide, you say carbon dioxide. I say methane, you say methane. I say nitrous oxide, you say nitrous oxide. C, mineral extraction, commercial logging, commercial agriculture and hydropower. D, drip tips or buttress roots. E, tourism, solar energy and farming. F, cloudy with precipitation. G, relief rainfall and frontal rainfall. Next step, read the recap reading. I'll read the reading with you and then we'll move on to 3. Last lesson, we looked at the greenhouse effect and we talked about how greenhouse gases in the atmosphere trap in long-wave solar radiation from the Earth and make the Earth's temperature suitable for life. We looked at the sources of the 3 greenhouse gases: carbon dioxide, methane and nitrous oxide. So the greenhouse effect we know is a totally natural process by which gases that exist naturally in the atmosphere trap in the sun's long-wave solar radiation. Without the greenhouse effect, the Earth would not be hot enough for life to survive. Number 3. Using the diagram below, answer the questions on the greenhouse effect from memory. Let's scroll down to those questions. Question A, what is stage 1 of the greenhouse effect? So look at the diagram, find the box numbered 1. What is the first stage? Then you want the second stage for B. So look at the diagram, this is box number 2, next is box number 3, next is box number 4. So this is just recapping what we did last lesson. Do it from memory. We'll repeat this a few times in the lessons that come up, and I just want you to see if you can improve your score. Give questions A to D a go. Pause me while you do that. Okay, stage 4. Correct your answers in green pen using the answers on the next page. A. The sun emits short-wave radiation. The first step is that short-wave radiation coming from the sun. Then the Earth's surface absorbs the short-wave radiation. So short-wave radiation comes from the sun, it travels all the way to Earth, and then it gets absorbed, it gets taken in by the Earth's surface. Then the Earth emits long-wave radiation. Right, so that short-wave radiation that's come from the sun has been absorbed by the Earth's surface, and then it gets re-emitted, it gets released by the Earth's surface. But this time it's not short-wave radiation, it's long-wave radiation. And it's that long-wave radiation that at stage 4 gets absorbed by the greenhouse gases in the Earth's atmosphere, making the temperature on Earth suitable for life. Pause me while you make any corrections in green pen. Off you go. Okay, stage 5 then. Now we're going to start the reading on the enhanced greenhouse effect and answer the questions. We'll read through the first paragraph, we'll summarise it together, and then you can answer questions 6 and 7. So, the enhanced greenhouse effect. The greenhouse effect is natural. There have always been greenhouse gases in the Earth's atmosphere because they are created by volcanic eruptions, decomposing organic material, and they are released by bacteria in the soil and oceans. However, humans have created the enhanced greenhouse effect by adding more greenhouse gases to the atmosphere. Today, there is more carbon dioxide in the atmosphere than there has ever been in the past 800,000 years. During the 20th and 21st century, the level of carbon dioxide rose by 40%. Right, now let's summarise what that means together. So we know that the greenhouse effect is natural. We've just summarised what the greenhouse effect is when we did those questions before. But humans have increased the greenhouse effect by adding more greenhouse gases to the atmosphere. We call that, when humans are doing it, the enhanced greenhouse effect. Okay, because it's like the natural greenhouse effect, but now it's enhanced. Enhanced means like bigger. So it's happening more because humans are adding more greenhouse gases to the atmosphere. And look at that fact right at the end. There is more carbon dioxide in the atmosphere today than there has ever been in the past 800,000 years. So, question 6. What is the difference between the greenhouse effect and the enhanced greenhouse effect? Then move on to question 7. Why has the amount of greenhouse gases in the atmosphere increased? Pause me while I answer those 2 questions. Alright, let's move on to the second paragraph now. So we're tracking from we produce, I'll read it, you follow. We produce greenhouse gases in lots of different ways. Globally, 25% of greenhouse gases humans produce come from producing electricity and heat to use in businesses. It doesn't include electricity that you use at home. Across the world, most electricity is produced by burning coal, natural gas, and other fossil fuels. This releases greenhouse gases that were stored underground. Fossil fuels were formed over 300 million years ago in the Carboniferous period. I say Carboniferous period, you say Carboniferous period. One more time. I say Carboniferous. I say Carboniferous period, you say Carboniferous period. Let's do it slowly now. Carboniferous, you say Carboniferous. Tricky word. That's just a period in the Earth's history. So, fossil fuels were formed over 300 million years ago in the Carboniferous period when the Earth had lots of shallow seas and swampy forests. Right, let's summarise what that reading is trying to tell us. People produce greenhouse gases. So, greenhouse gases exist naturally, but people are adding more greenhouse gases to the atmosphere. And a quarter of those greenhouse gases that people are producing come from producing energy. That's electricity and heat to use in businesses. So most of the energy that we use in society is used in businesses. It's not used in your houses. And we get that energy from coal and natural gas. So in power plants, coal and natural gas are burnt. Let me rephrase that. In power plants, coal and natural gas are burnt to make electricity. When they are burnt, they release carbon dioxide. Now, what we're going to do is have a bit more of an in-depth look at what fossil fuels are. So remember that the examples of fossil fuels we looked at are coal and natural gas. They're fossil fuels. And they were formed 300 million years ago in a period of the Earth's history called the Carboniferous period. And in that period, the Earth had lots of shallow seas and swampy forests. Swampy forest, that's just like a really wet forest. Now, there are 3 stages in the formation of fossil fuels. Stage 1, we're looking at the first picture now, stage 1. Dead animals and plants sink to the bottom of oceans. Stage 2. Over time, the dead animals and plants were trapped beneath a layer of sedimentary rock. So the dead animals and plants sink all the way down to the bottom of the ocean. Then other stuff starts sinking down on top of them, and it gets compressed, it gets squished at the bottom of the ocean. That's stage 3. So over time, the sedimentary rock gets compressed, and the dead plants and animals beneath it gets compressed, and they get turned into coal, oil, and natural gas. One more time then, let's go through that. Dead animals sink to the bottom of the ocean, stage 1. Stage 2. Those animals get squished or compressed by sedimentary rock. Stage 3. When they're being compressed, they turn into coal, oil, and natural gas, and those are what we burn to make our electricity. Scroll down now, you're on the black box with question number 18. Read through the diagram, that's the diagram above here, of how fossil fuels were formed. And then answer these questions. What is the first stage of the formation of fossil fuel? So it's really important here that you read through the diagram You don't look back at it. Then you answer the question. So just like you would do with a knowledge organizer, you read through, you explain it out loud, but you don't look back at it when you answer that question. So question 8, read through the diagram, don't look back at it, then answer questions A to D. Pause me while you give that a go. Alright, so using a green pen, correct your answers. Here are the answers. For 6, 7 and 8A to D. If you haven't got questions 8A to 8D correct, just have a go at re-quizzing them. The formation of fossil fuels, that might take some goes to get into your mind because there's a 3-stage process to that. If you need to have another go at that because you haven't got them all right, give that another go now and pause me while you do that. If you got them all right, let's move on to the greenhouse effect reading. I'm going to read through this reading with you. Just track the reading while I read through it. In the reading, there are going to be some tricky words like absorb. Absorb means to take in. Livestock are animals that are farmed, so sheep, cows. Fertilise. If you fertilise something, you add nutrients to the soil. Before we've talked about a soil being fertile. A fertile soil is soil that is good for growing. So you fertilise a soil to make it fertile. And fertilisers are chemicals that farmers can add to the soil which fertilise it. So fertilisers are chemicals that farmers add to the soil to add nutrients into the soil. Okay, track the first line of the reading, roughly. Roughly 1/5 of all global greenhouse gas emissions come from the way we use our land. Many of the world's forests are being deforested. Land that used to have trees on it is now mainly used for agriculture, although some land is also used for hydropower, commercial logging and mineral extraction. We looked at this when we studied the rainforest. Cutting trees down means that carbon dioxide builds up quicker in the atmosphere because there are no trees to absorb it. The agriculture machinery used by farming is powered by diesel or petrol, which come from oil. Oil is a fossil fuel, so burning diesel and petrol releases carbon dioxide and nitrous oxide. Livestock farming releases greenhouse gases because the livestock themselves release methane through burping and farting. Actually, cows produce more methane by burping than they do farting. Out of all livestock, cows produce the most methane, but sheep and pigs also contribute. But crop farming also produces greenhouse gases because farmers fertilise their soil with nitrogen fertilisers, which react with the oxygen in the air to create a greenhouse gas called nitrous oxide. Okay, let's just summarise what that paragraph means. So a significant amount, 1/5 of all greenhouse gas emissions that people produce come from agriculture. We know when we looked at rainforests that if land is deforested, the trees are cut down, right? So these trees can no longer take in carbon dioxide from the atmosphere. And that means that there's more carbon dioxide left in the atmosphere. Most of that land is then used for farming or agriculture. It means the same thing. And agriculture produces greenhouse gases in different ways. First, agriculture machinery, so things like tractors, combine harvesters, they've got to be powered by something, and they're powered by diesel or petrol. Diesel and petrol come from oil, and remember from our fossil fuels that we studied right back here, oil is a fossil fuel, so it's made from dead plants and animals that have sunk to the bottom of the ocean. Because it's a fossil fuel, when you burn it, it releases carbon dioxide and nitrous oxide. So, tractors, combine harvesters, any agriculture machinery, that's going to produce greenhouse gases. The livestock themselves, so the cows, the sheep, the pigs, they also release greenhouse gases. They release a greenhouse gas called methane, and they do that through burping and farting. But even if you are farming crops, you are still producing greenhouse gases. That is because the farmers use something called nitrogen fertilizers. Nitrogen fertilizers are put in the soil to add nutrients to the soil to make the crops grow faster. But the nitrogen in the fertilizer reacts with the oxygen in the air, creating a greenhouse gas called nitrous oxide. Using the reading, have a go at answering the questions in the black box. Pause me while you give that a go. Okay. Scrolling down to the next page, using a green pen, correct your answers. Pause me while you correct your answers. Alright, good effort. So, I know that everyone works at different speeds. If this hasn't taken you an hour, use the rest of this time to read-quiz from the Weather and Climate book until you've worked for an hour. If this has taken you an hour, great, good effort today. That's all from me. Thank you.